Today, we will be presenting our algorithmic trading and backtesting system utilizing moving average and z-score breakout strategies. My name is Roger Padilla, and this is my teammate.
And my name is Joe Van Deng, and we are students in the real-time system course taught by the SEPs. Let's go next.
So our project scope, this project implements a real-time trading software that allows sending orders. It includes features to store the current capital and holdings, enabling backtesting of strategies. By monitoring the profits and losses, holdings, and overall performance in real time, this system provides a comprehensive view of the strategy execution. So once we kind of got into our project solution, we developed a socket-based algorithmic trading system with real-time client-server communication. This server provides, real-time historical market data to our clients. The client then utilizes the given trading strategies to generate trading signals based on the data that comes in. Our server then processes the trading orders received from the client, updating holdings accordingly within our system. And once we come to kind of a high level of our software architecture, essentially a client receives the data, kind of harnesses it and acts on it to produce these signals. It doesn't share resources, but it does continuously request content from the server. The server then runs one or more programs that share the resources and, distribute this work and information among the clients. It could be a database or a web server. In our trading system, the server sends out market data every second for a single stock that's predetermined. In our case, we used Apple. Our client then collects so yeah, once we get into kind of our implementation, we started with, our trading server. Essentially, our trading server, we implemented a Python class. We set up a TCP socket server on a specified host and port. This reads the historical market data from a CSV, sends it to the connected client in a streaming manner, one row at a time. So essentially our code, it initially defines a server class. This server listens to a specified host and port using a socket. It has the methods to send the CSV data to the clients, convert a string to a JSON format, and send a stream of data to the client. The server then listens for the client connections in a loop, and for each client, it creates separate threads to handle the client's request and send the data stream. This server also has a method to handle the client's answer, which updates the server's holdings based on the client's direction and amount. So once we kind of move towards our clients, on the next slide, the second part of our implementation, we also implemented it as a Python class. It establishes connection to the server to receive this market data, parses incoming JSON data to extract date, closing price, current holdings, etc. So yeah, essentially from a high level, this code creates, we defined a trading client class. We call it trading client, connects to the server, receives data, uses a trading strategy, and sends orders based on that received data. The client connects to, a specified host port using a socket. It has methods to handle the received orders, send the order to the server, and update the client's capital based on that order. We use a connect method that establishes a connection with the server and continuously receives data in an infinite loop. For each kind of data that we receive, the client processes it, generates an order using our trading strategies, sends the order to the server, and updates the capital based on that order again. So I guess we'll move on to the next slide.
And thanks, Roger. So I will introduce the diagram of our the diagrams of our client and server communication. So first of all, we have because we don't have a real time data feed, so we simulate a server to send out the the data stream to the clients. And for this server, as Roger introduced, we have to handle the clients, and because we are import data from a CSV file, and to just to some data that the server can understand, we have to transfer the CSV file into some format, which is the data and which is data transformation, and we also have to transfer the data we received to the clients, which is some from the JSON to some encoding, so like a UTF-8. So for this one, we also have the multi-threads to handle the clients and handle the client's answer. So from the server to the clients, we just send the real-time data streaming to the clients, and the clients also have to handle the orders. For example, after we receive the data from the market, which is the day data, we have the data inputs, and we connect the clients to do some strategies, which are strategies we come up with here. And in the strategies class, we have to analyze the data we gather from the server, and use some different strategies like the moving average or zero z-score breakout, and we can generate some signals. By the guidance of these signals, we can generate some orders, and like we have to buy what is the direction, like a buy and the amount of buy. And if signal is a sell, we have to sell, and we have to sell the holdings we have. So which holdings and the current capital is stored in somewhere in the system, like Roger introduced in the previous slides. And that's the overall software architecture of our program. And though actually in this project we're using two strategies, and we also post the results right here. And the first strategy we use is the moving average. And actually this one, well, for these two strategies, we are using the Python classes and to represent. And for the moving average, we just it's mainly like we have stored the 50 days data and 20 days data in the two decks. And in this deck, the reason we use decks is because we can just easily remove the elements in the front, and we can add elements in the end of the deck. And to analyze the deck, the 50 days window and 20 days window, we are using different metrics. Like if the average of 50 days is greater than the average of 20 days, we generate some signals, and vice versa. And we also have a buy and sell signals based on the crossovers of the two moving averages, just like I said. Yeah, and the picture we post here is the results of our program, and we definitely will demo the programming later. And the second training strategy, so we use the z-score breakout. Like we store the data in the same deck, but in here in the same rolling window, like with the window we chose is 60 days. But here the differences from the previous strategies is that we are using the data we subtract the data from its average, and we can calculate the data spread. And for this spread, we can calculate the standard deviation. And the whole idea is like normalize the data into a z-score distribution, and we to see if the z-score is above any threshold, or the z-score is changed. The sign of z-score is changed. So these two signals can be generated by the z-score drop below a threshold or sell signal when some signals are crossed. So the picture here is also the results of our program. And I can share the program right here. And this is our program. And as we introduced, we have for server part, we have a established a server socket, and we also have a listen to client. So here we have a threads handling the clients, and also we have to handling send the stream to the clients, and also we have to send the CSV. And for this one, because we're reading the CSV we're reading CSV, so we have to convert it. We have to do a data transformations. And also from here,
I think you're on the wrong screen.
Oh, this one?
Yeah.
Oh yeah. And for here, we have to send the screen to
on the wrong.
Still wrong?
Yes.
It's a server, right?
I see the PowerPoint.
Oh. how can I share my screen? Let's go this one. Can you see my screen?
There you go.
Okay. So as we taught as we taught in the PowerPoints, we established the server, and this is a structure of the server. Like this is listen to the clients, and this one we have the different threading handling the clients, listen to the clients, and send the CSV. And here we just it's a big structure of the socket in the for the server, and for this too, because we are reading the CSV file from the outside resources, so we have to do some data transformation as we mentioned, and this is the UTF function for send a stream to the clients, and also we have to listen to the clients because of the wait for the client's connection, and after we we hear from the clients, we have to handle clients answer because we have to know their orders, and we know their decisions, and we can change on our side. So for the clients, definitely we have a same portal which we run the the whole client and server on our local, and we have our strategy. This strategy is subjected to change, so we can change strategy in the client server to test different strategies. And this one we just received from here. We just received the data coming from the server, and here we just generate some use the data we received. We have to generate some orders, like we have to buy such amount or we have to sell such amount, and this order is totally depend on the strategy we use. And if after we generate the order, we just send the order to the server, and we have to we'll have to also handle our order, like what is the capital, what is the remaining the holdings, and we have also print the the cash remain, which after we send the order, how many cash we still have in our side. So, and for the strategy part, as we mentioned, we have two. One is a moving average strategy, and the second one is a Z-score breakout. And the design of the two strategies is just like the what we mentioned. And now I have to start demo our program. First of all, we run a server. Stop and run. So on the screen, we can see the server established, and we are listening for the clients. And now we can just run in the clients. Because here the strategy we generate is the Z-score brick, and the fraction means that how many capital we have to use to buy the the stock. So you can see right here we are quickly receiving the data coming from the server, and here first of all we generate something because we can see the holding is changing from here, and can date received is the 2014 January 29th, and here our money is reduced by a fraction of 0.1, so which means that like around like $100,000 that is buying the stocks now, and we have holdings of this much, and we can see that as long as we continue, the holdings is increasing because we generate some signals, and our cash is reducing all the way until if you had a sell signals right here. So our cash from the around like I don't know $400,000 to $1 million, and this is a signal of buy of selling, and we can see this streaming continues all the time, and it still keeps streaming. And if we change a strategy to another, like MA, and we run the program again, and we will show this is the backtesting for another strategy, the MA. and we can still wait until we have a change of holdings. And here it is. We can see the signal is changed. So which means that there is a signal we have to buy or sell the holding we have. Of course, I mean, here is buy because we don't have holdings, and we can see here like our cash from the million to the $900,000, and we have holdings this much, and continue to the end of the holdings. I mean, here we also have another signal change, so which means that we have to sell all the holdings, and we can see the money increased from the 900,000 to around a million, which means that we have to we can continue to see that our cash is still remain this much, and until next the signals. So I mean, this system is capable of back testing our strategies by receiving the real-time data from the server, and of course in the end we can add more functions to our system, and I will share trading to the is that correct screen?
Yes.
Okay, yeah, that's great. Slideshow. So for the to conclude the project, so our main accomplishment is that the project definitely combines the Python socket programming, multi-threading, even DAX and JSON parsing to create simulated real-time algorithmic trading system. And also this system is capable of backtesting the strategies, because you can show all the performance and the holdings and how many cash you remain and in the system. So in the end, you can check how is your strategies is good or not. And also we provide a platform for testing and analyzing the different trading strategies based on historical market data. And as long as you have a different market data, like this time we use the Apple, probably tomorrow we will use Google or something. So we definitely are capable, this program are capable of analyzing any of the historical market data. And then of course we have a lot of work to do in the future. For example, we can add more complex trading strategies, because MA and Z-score breakout is kind of simple strategies, and definitely because the reason we are using class is that we can add any more extensions anytime we want. So that's one advantage of our system. And also we can add some functions such as the plotting and the backtesting tools, like calculating the Sharpe ratio or plotting the the real-time data, the real-time data in the plotting the data in real time. And we also have we can also add some tools for risk management, and we can also expand the system to support the real-time data phase. Like we don't have to simulate the server, and we can just because nowadays currently we are trading one single data. So future, I think we can add more features that we can support to trade the multiple assets classes. Like we can trade the Google, Amazon, or Apple stocks anytime, instead of just a single stock input. So that's kind of all presentation of our project. And thank you, Roger, for the help of the project. And that's kind of.
Thank you very much. And I guess that concludes our presentation.